Ampere was a French physicist and mathematician born in 1775. He was one of the founders of classical electromagnetism, which he referred to as electrodynamics. He also invented some other insignificant stuff that no one but scientists really care about, like the solenoid, the concept of the electron, and the electrical telegraph. He discovered fluorine and grouped elements together by their properties well over half a century before Mendeleev produced his periodic table. So, if you think about it, you really have him to blame for your nightmares about high school chemistry. He did actually end up being recognised for his work. His name and achievements are on a plaque outside the Eiffel Tower, which I think is peak fame for the French. Being brutally honest, Ampere didn't even come up with the experiment that proved his law. In 1820, he heard that native Dane Ørsted had deflected a compass needle by passing an electric current nearby. By the end of the week, Ampere had jumped on the bandwagon and began quantifying the relationship between magnetic and electric fields.
Here we have a power supply supplying 5 volts and, as you'll see in a second, 5 amps to that resistor box over there. We have wires coming from power supply running in very close proximity to each other, situated right above the scales. When we switch the power supply on, you will see a slight force exerted on the scale, demonstrating Ampere's law in action. To calculate the force exerted on a bottom wire, we will need to use Ampere's law with an appropriate Amperian loop and an electric flux component cancelled out due to direct current, which drastically simplifies the problem. After solving an easy integral, we can plug the resulting magnitude of the magnetic field back into the original equation and end up with an expression for resulting force. From our experiment, we get the following measurements for length, current, and distance between the wires. Plugging these numbers straight to the derived equation effectively demonstrates that Ampere was right.
Ampere's work in the field was already well established by the time Maxwell came along and applied his laws to time-dependent conditions. While Ampere was working on his law, there was another physicist across the channel who was working on what would become his own law. Faraday was also inspired by Ørsted's work, but his own publication was overshadowed by a row over plagiarism. But this was the 19th century, so they couldn't exactly subtweet each other. Instead, Faraday published an entire paper on why Ampere's view of electrodynamics was flawed.
Wait a fucking minute, you're talking a load of shit. Let me show you how it's done through this sick rap diss.
Throwing it back to 1791, new but to England, yeah, a legend was born. Good in my hands and a hella big brain, I got by and only basic trigonometry.
Hold up, it's your boy Ampere. There's a few things I'd like to make clear. You died of something, but you came from nothing. Almost killed yourself in Davy doing a different subject.
My breakthrough came one day in the lab, and I can tell you now it's the best I ever had. A momentary current in another coil. Mutual inductance, yeah, it had us all riled. It all happened rather unexpectedly, and when it did, they all chatted Faraday. I died before they listened to my field theories, but it doesn't change the fact that I'm the real OG.
I established my laws with complete precision. Tough shit if it's just in magnetostatic situations. I wouldn't be boasting about your abilities. I came straight out of École Polytechnique. I will destroy you with my mathematique. Watch your back on the streets.
Oi Ampere, I want boil your heat. Think you're special thinking of the term electrodynamic without me. There'd literally be no light, and that there is something that your money just can't buy. Then he slagged my homeboy, Faraday. I was voted 3rd greatest scientist in history. I laid the foundations of special relativity. What I say goes, and your diss is obsolete.